For this story proof, we're asked to prove this identity here. To do this, consider selecting, according to the hint in the book, we consider selecting a committee of n people out of a total of 2n people. And we think of these 2n people as grouped into two groups of n. So we have a group here of size n, and we have a group here of size n. And in the hint, we're also told that we should think that a committee chair can only be selected from one of the groups. So let's say only this group can give a chair for a committee. So let's first consider the right-hand side. So for the right-hand side, let's say right-hand side, there are n ways to select a chair for our committee. Now, once we've selected a chair, we now have a total of 2n minus 1 people. And out of those 2n minus 1, we need to select n minus 1 for the remaining n minus 1 members of our committee. So, out of the remaining 2n minus 1 people, select n minus 1 members. So in total, we have n choices from the first group for a chair of the committee, and then for each such choice for the remaining 2n minus 1 people, we select n minus 1 members for the committee. Now let's look at the left-hand side. So for the left-hand side, let's consider this. Let's rewrite this summation in the following way. So k from 1 to n, k times n choose k, and we know that n choose k is the same as n choose n minus k. So the reason we do this is because this expression here makes it clear that we're considering selecting k people from the first group, and then n minus k people from the second group. And we know that we need to have at least one person from the first group because only the first group can give a committee chair. That's why k starts from 1 and not 0. And now once we've selected k people from the first group, how many choices are there for a chair? Well, we selected k people from the first group. Each one of those k can be a chair. So we have k ways to pick a chair. So what is this counting? This is essentially saying select k people from the first group, n minus k from the second group. In other words, we just selected a committee of size n, and then from the k people that we had selected from the first group, pick a chair. And we have k ways to do that. So this is also counting, so this also counts total number of ways to pick a committee of size n from 2n people, where at least one of the people needs to be from group 1, and a member of group 1 needs to be selected as a chair. A member of group 1 is selected as the chair. Right? So one more time. So on the right-hand side, out of the total number of people, we look at the first group. Out of this group, there are n choices to pick a chair. We pick our chair, and now out of the remainder 2n minus 1 people, we pick n minus 1 of them to complete our committee. On the left-hand side, what we do is we break up the selection process into cases. And the cases are how many people we select from the first group. So we select starting from 1 person all the way to n. Every person could be from the first group, right? And for each such selection of k people from the first group, we have k choices of the number of assignments of chair, because each one of those k people can be assigned a chair position. So since both the left-hand side and the right-hand side count the same thing, we've proven this identity.